All right, now we're going to look at how to evaluate polynomials with synthetic division, and in order to do that, we also just need to recall how to evaluate polynomials. So we're going to figure this out with synthetic division, but first I want you to actually just evaluate this polynomial when x equals -4. This is something we've done earlier in the year, so pause the video, do that, unpause when you're ready to discuss. All right, so hopefully you got -359, and remember, evaluating any function just means plugging this number in for the input and finding the output. So f of -4, or evaluating at x equals -4 means I'm going to plug in -4 for x, so I do f of -4, so 5 times -4 to the third minus -4 squared plus 13 times -4 plus 29. Be very careful typing this into your calculator with the parentheses. Your calculator will do the order of operations for you. Here you can see my work here, and this is what I'm talking about. Notice how I actually put those parentheses in, and then I just hit enter and I get -359. So remember that this tells us the point -4, -359 exists on this polynomial, right? So if I was to graph this polynomial, I know one of the points it would go through would be -4, -359. Okay, now we're going to look how could I know that information from synthetic division. Well, let's do synthetic division of this polynomial. Our k value, notice that this is already x equals -4. So as opposed to saying like x plus 4 is what I'm going to divide by, where I would set this equal to 0, and I would solve, I already have solved. So the -4, is what is going to go in my corner. So I'm going to do -4. And then our coefficients, so 5, -1, 13, and 29. Okay, I want you to pause the video and finish the synthetic division because we want the practice, but unpause when you're ready to check. Or if you have any questions. You got this though. All right, so here is my synthetic division process. 5 plus 0 is 5, -4 times 5 is -20, -1 plus -20 is -21, -4 times -21 is 84, 13 plus 84 is 97, -4 times 97 is -388, 29 plus -388 is -359. So if I was writing the result of this synthetic division, which I don't have to do for this problem because that is not what the problem asked me to do, but just for fun, funsies is sometimes what I like to say. This would have been my result of synthetic division. But again, that is not what the question is asking for. The question wanted us to evaluate f of -4. Take a look at my results. I'll give you a hint. Where do we see our result of f of -4? I'll give you a hint. I'm not going to tell you what the hint is, but I'm going to give you a hint. Very good. It's the remainder. So what this tells us is whenever we do synthetic division, the remainder is also the same as the value of the number we put in the corner of that polynomial. So if I say evaluate a polynomial using synthetic division, then you are going to do the synthetic division and your answer is the remainder, or the value of the remainder. Generically, what we would say is f of k equals r. Because remember, when we do synthetic division, we always divide by something of the form x minus k. So in this case, k was -4, r is the remainder. So for this problem, this is f of -4 equals -359. All right, I want you to try this. So use synthetic division and find the value of the polynomial when x is 5. Pause the video, unpause when you're ready to check. All right, here, hopefully this one was pretty quick because it's just a second degree polynomial. So we have x equals 5, and again, I want to emphasize, notice that this is x equals 5. It wasn't x minus 5 or x plus 5. It is already solved for x, so we don't have to do that step for the synthetic division that we were doing when we first just learned about synthetic division. So the 5 is the k value that I just put in the corner right away. Okay, coefficients are 4, negative 10, and negative 21. Boom. 4 plus 0 is 4. 5 times 4 is 20. Negative 10 plus 20 is 10. 5 times 10 is 50. 50 plus negative 21 is 29. So f of 5 is 29. All right, I'm pretty sure you're getting this because you're not really asking any questions, but let's try one more just for funsies. Go for it. You got this. Pause the video. Unpause when you're ready to check. Evaluate f of 2. All right, so hopefully we got f of 2 equals 50. So that is the value of the polynomial when x equals 2. How do I get that? Again, here's my synthetic division. So I set this up, put 2 in the corner because this is already solved for 2. My coefficients are 5, 2. There is 0x squared. Did you fall for that? No, you didn't. I know you didn't because you saw that. And then minus 20, and then minus 6. So I add vertically. 5 plus 0 is 5. 2 times 5 is 10. 2 plus 10 is 12. 2 times 12 is 24. 0 plus 24 is 24. 2 times 24 is 48. Negative 20 plus 48 is 28. 2 times 28 is 56. Negative 6 plus 56 is 50. Whew. All right. Now, notice another thing I want to point out. Notice I'm not writing the result of the synthetic division. And by writing, I mean I'm not writing 5x to the third plus 12x squared plus 24x plus 28. And then plus 50 over x minus 2. I don't need to do that because the problem wanted me to evaluate, right? And so if this is just saying evaluate, then I don't have to write the result of the synthetic division. I just need to do the synthetic division so that I can get to the remainder and know that my answer is the remainder. So this just goes to us paying attention to what are the directions asking me to do, right? We have to read. Left to right, top, bottom, group of words as a sentence, that sort of thing. All right, so synthetic division only works when we are dividing by something of the form x minus k, but when we are using synthetic division to evaluate, then we are just plugging k into the corner, and we are finding the point k comma r, where r is the remainder, and so that is the value of the polynomial at the point at the x coordinate k. So when we are evaluating a polynomial with synthetic division, we just care about the remainder. That is our answer.